This is my final project for LIS 4761, Intro to Data and Text Mining. In this project, I had two data sets, one from the Florida Department of Law Enforcement showing the arrest data for the 67 counties in Florida, and another showing library usage data from all of the libraries within the state. Our goal with using both of these data sets, is to see if there is a correlation between the amount of people arrested and the usage of the library in each county within the state. This is the arrest and the offense data for the Florida Department of Law Enforcement from 2017. This data set came with many observations over many variables, and what we wanted was just the county name, the population, the total number of arrests, and the total number of offenses. And if you look here, you'll see that that is what we have. County, population, arrests, and offenses. Besides weeding down the data like we did to get those four, I also modified specific county names like St. Lucie County and Fort Myers County to make sure that it would be able to read for when we imported this data into the ggplot maps. This is the library usage data from the libraries in the state of Florida. This was an annual report that they that they had done every year, and this is from 2017 to match the arrest data that we have from the law enforcement. One of the things that I did in Excel was assign libraries that are not part of their county system a county and then total it up. Another thing that I had to do to make the data okay was there were several cooperatives that form over multiple counties. So for those, I had to break them up and divide the data into those specific pieces. As you can see, what I did was I merged the library data with income, staff, circulation, which is check-ins or checkouts, checkout materials, borrowers or patrons, visitors of the library, and reference questions, as well as the region of Florida, onto county and population, which we got from the Florida Department of Law Enforcement data. Now here are the histograms that we have for each variable. As you can see, over the x-axis is the variable for each one: population, arrests, offenses, circulation, staff, income, borrowers, visitors, and reference. Here's the scatter plots. One of the things that I want to point out in the scatter plots is how linear they almost all are. As with borrowers and arrests, we see that as the arrest goes higher, so do the borrowers. And that we see that with circulation as well, with staff, with visitors. Not as much with reference, it's more wide, but with circulation and offenses, borrowers and offenses, and visitors and offenses. And make sure you look at the bottom, as some of them have arrest as the X, and some of them have offense as the X. But because of this, I realized that if a county has a higher population, they're more likely to have better library usage, and they're more likely to have more arrests. So what we did was we took the data and divided it by the population so that it would be a better factor overall. And then these are the modified histograms that are a little less skewed to the left than their original ones were. And here are the modified scatter plots. Now these scatter plots are just with arrest on the X and then library usage data on the Y-axis. And as we can see, it's more varied. You have a lot more over here and then some up and some over here. And it's the same over here with this over here, and you have these many points over here. This one's unusual because it's all really focused on the bottom, which is interesting. And now here's the ggplotmaps that was really the basis of my project. As you can see, this one's just the region, so it won't tell us that much. So these maps are the ones that are very interesting, and with it we could see the different counties and how they relate to each one of the variables. So this county was really how I knew that something might be up. It was very high in arrests because the light blue is high. And then circulation, it was very low, and so too with borrowers. This county also low on arrests, as we can see here, and then higher on circulation and also higher on borrowers. Now it doesn't always fit. You have counties like Miami-Dade who are medium on arrests but lower on library usage. And then we'll also count this one too. That's medium on arrests but very high on library usage. So we have to go into more analytics to see if this correlation actually exists. This is the heat map, and I included it because I thought it was very interesting, and it's interesting because I can follow the data points over and across and see, oh, this one had a lot of reference transactions. I'm looking at this point right here. And if we follow it across, it has a higher than usual amount of arrests according to the rest of them. And if we look here, this one has a higher amount of arrests, and if we follow it along, we get higher-ish library usage all the way across. So this points that it doesn't always work as how we expected it to. I had not planned on doing this, but after all of the visualization, I decided to do some correlation tests. So to prepare for that, I took our scatter plots and added line graphs to all of them. And as you can see, the graph isn't great. Like, I would have expected a graph like this if our correlation was going to be true for each one. And as you could see, that did not happen. So for each correlation test, I did several. I did method Spearman, method Pearson, and method Kendall. And for all three, it came out that the p-value was not significant, so we could not ignore the null hypothesis and be known that there was a correlation between the two. So as of right now, as of with our data, there is no correlation between crime statistics and library usage. I also included the Shiny app as part of my project. So if you go to this URL here, you can play with the graphs, and this is just a screenshot of it. And you have map 1 and map 2. And you can compare the different data together and see like we did on the previous slide. So for this final project, I used 3 lessons: Module 1 with much of the visualization, Module 2 for the maps, and then Module 10, I believe it was, for the Shiny app, the last module. I hope you enjoyed this project, and thank you very much for a great class.